So let's talk now about the idea of actually finding probabilities, and we're going to use TC stats to do this. So here's a quick example. Wine manufacturers are very cognizant of the extraction force required to open a corked bottle of wine. It's considered an industry standard for the average force to be 305 newtons, which is just a measurement of force, with a standard deviation of 28 newtons. Okay, so what they just told me here is that the mean mu is 305. That's what it needs to be. And the standard deviation, sigma, is 28. That means the variance, sigma squared, is obviously 28 squared. Now, let's see. A bottle requiring less than 240 newtons will not be sealed tight enough. And a bottle requiring more than 378 newtons will be too tight for most consumers to comfortably open. 1 newton equals 1 kilogram meter second squared, which is, this is the definition of newton. That's the amount of a force, as a measurement of force. Now, assuming the distribution of force is distributed normally, find the following probabilities. Well, the first one says find the probability a random selected bottle of wine will require more force to open than would be considered comfortable for the average customer. Well, let's go back and do a little bit of notation here so that we can work this thing out. And I'm going to use F as my random variable. Why not force? So force is believed to be distributed normally with a mean of 305 and a variance of 28 squared. This is extremely important. It just specified our distribution, so we will be able to find probabilities with it. So we want to find the probability a bottle of wine will require more force to open than would be considered comfortable. That is the 378. So let me go back up here. Newtons, let me see. A bottle requiring less than 240 would be not sealed tight enough. A bottle requiring more than 378 will be too tight to be comfortable. So what this is saying, a probability statement, is I want the probability that force is greater than or equal to 378. Now, something that's important here about this greater than or equal to thing. I'm going to digress here for just a moment. This is a continuous distribution, and one of the properties of a continuous distribution is it does not matter if I write this as greater than or equal to, or if I write it as simply greater than. Now you recall that we said that the area under the curve is associated with the probabilities. So here I have a mean of 305, and I want to go, say, 378. Let's just say I want to go 378 to 390. I'm just making this up. Well, the probability of being between 378 and 390 would be the area under the curve right here. So if I wrote this as I want the probability that 378 is less than the force, which is less than 390, that means I am excluding these endpoints. Now in a discrete distribution, that's extremely important. In a continuous distribution, it doesn't make any difference. I will get the exact same answer if I exclude those or if I include them. It doesn't make any difference. And the reason for that, we need to talk just a really brief calculus concept here. The way we calculate this area under the curve, what the calculus technique actually does is from the left endpoint to the right endpoint, it's going to break these up into little boxes. And you know, if you know the width and the height of a box, then you can find the area of the box. Well, if I take these widths of these boxes and I let them get infinitely small, I'm adding up an infinite number of boxes, which gives me an exact area under the curve. So if I have a height and a width, you know that the area equals height times width. Well, if I include this endpoint here, what do I have? Well, the height I can figure out. I can figure out how high that is. But the width equals 0. There is no width. Because including the endpoint means I'm including the area that's associated with this line. And a line has width on a paper so you can see it. But in mathematics, in nature, a line is infinitely thin and has no mass. So what I'm really doing by including these endpoints is I'm adding 0 probability on both ends. Hence, it doesn't really make a difference if I include it or exclude it. Now, if you do happen to have a little bit of calculus, I'm going to throw one more thing at you here. If you take an integral, this is only if you have calculus. If you haven't had a calculus background, then ignore what I'm going to do. This won't make any sense to you. If I integrate from a to b of f of x dx, we know that is f of b minus f of a from the fundamental theorem of calculus, where the capital F is the antiderivative of little f, right? Okay, so if I integrate from a to a, which would be like adding that endpoint, finding the area at one single point of f of x dx, this would be f of a minus f of a, which is always 0. So with just a touch of integral calculus, I can justify why adding these endpoints, adding the area of a line, is 0. What that also means on a continuous distribution is that anytime you have a statement, what's the probability that f is equal to exactly 378? Because I know this distribution is continuous, right away I know that is going to be 0. It's not possible to have exactly 378. Now, you may say, well, of course it is. I can get 378. Well, in reality, you can't. You can get so close. It may be 378.00000000001, but then you're going to lose your ability to measure it. It's really not even physically possible to get exactly 378. If you want to find the probability of 378, there is a way to go about it, and basically what you'd say is more like this. You say, what's the probability of being 377.5 is less than or equal to the force, which is less than or equal to 378.5. What that's doing is that going like halfway in between, and that's a reasonable approximate for being in the immediate vicinity of exactly 378 newtons. But we don't typically do that sort of thing. You can, but we wouldn't necessarily. Well, matter of fact, I don't think we'd ever do that necessarily in this class. So, back up to here. I now need to solve this problem. What I have is I need to find the probability that the force is greater than 378, and there's some key information right here. So the very first thing I'm going to do is draw a picture. When I draw the picture, it's always going to be a bell curve. The mean is 305. 378 is up here someplace. It doesn't really matter if I place this in an accurate position or not. This is just used as a diagram to help me figure out what I'm doing. So greater than 378 would be all this area here. So I need to go from 378 out to infinity. So that means that the lower bound, where I'm starting to calculate, is going to be 378. And the upper bound is going to be positive infinity. Now I need this information for TC stats to actually calculate the probability. So here I am in TC stats, and I have a bunch of data sets here, but none of them are really needed. I don't need data for this. So I'm going to select analysis methods without data. And that will give me access to all the probability distributions I need. So I will select probability distributions, and you can see the second one is normal. It's right underneath the binomial PDF and CDF. Now this asks for some information, some basic information that you need provided. It needs to know the mean, which we said was 305. And you see here it needs a standard deviation, which remember we said the distribution had a mean of 305, a variance of 28 squared, so the standard deviation is 28. And it needs n. Now, in this entire chapter, when we're talking about n, we're talking about 1. It's always 1. It's what's the probability I reach into this population, I grab one bottle that has a requires more than 378 newtons to open. There's always 1. If I have the distribution of IQs, what's the probability I reach into this population and grab one person whose IQ is greater than 120 or 120 to 130, what have you. It's always, 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 for this chapter, 1. What happens in the next chapter is we say, hey, look, what happens if we have an average so n changes? Now, the lower bound, we said, based on our statement, was 378. And the upper bound, this needs to be infinity. Well, rather than trying to write in infinity, all we're going to do is we're going to check. We're going to turn this on for positive infinity. Likewise, if we're going to negative infinity, I wouldn't put a number here. I would just check it here. So do that. And now I'm ready to go. If I simply tap on calculate, I get the probability. It's 0.0046. You can see it right there. That's the probability. So what this is actually saying is this area under the curve is 0.0046. Now another interpretation for this is 0.46%. So less than 0.5% of all of the bottles would require more force to open than what the industry says would be comfortable. See, one of the interpretations for the area under the curve is it's the percent of the total. Okay, think about that for a second. It's the percent of the total. So if this probability is 0.0046, to convert that to a percent, just move the decimal over twice. Remember that from algebra. So this is 0.46%. So less than 0.5% of all of the bottles that satisfy this distribution are on too tight. The corks are on too tight for the customers to feel comfortable with them. So here's another example. Let's find the probability a randomly selected bottle of wine will not be sealed tight enough. Well, if you recall, less than 240 newtons was not tight enough. So this is really saying what's the probability that force is less than or equal to 240. And again, that's a matter of preference. It doesn't really matter if you put it in or not. So once again, I'll draw a picture. Whenever possible, always, always, always draw pictures. The mean was 305. 240 is somewhere down here. Again, it doesn't matter if I accurately place it or not. It's just below 305. It's just a diagram to help me. Less than 240 is going to be this. So I know my lower bound is going to be negative infinity, and my upper bound will be 240. So if I go back to TC stats, all this information will stay the same, but I need to get rid of this 378 and actually go to negative infinity, get rid of the positive infinity, and I'm only going to 240. So again, if I calculate, I'll get an answer. So 0.0101. So in other words, approximately 1% are not on tight enough. Less than 0.5% are too tight, and less than 1% is, or a little bit more than 1%, is not on tight enough. Now, what I didn't do in the first one, and you need to start doing, is the English statement. And the English statement is simply taking your findings and putting it into an English sentence or two, whatever's required, to state what you just found. So you would say here, I'm not going to write it, I'm just going to say it for you. You need to write it down. The probability that a randomly selected bottle of wine will not, or the cork will not be on tight enough is 0.0101. You need to say something to that effect. Those exact words aren't necessary, but that concept is necessary. Let's take a look at another example. Find the probability a randomly selected bottle of wine will require exactly 320 newtons to open. Well, the probability statement would be, what's the probability that force is equal to 320? And because this is the normal distribution is a continuous distribution, right away we know it's 0. If we draw a picture, we know 305 is the mean, it's right down the middle. 320 is up here somewhere. So I'm starting and stopping at 320. I'm asking for the area under the curve at that line. And I talked about that earlier and said that it was 0. And actually, if I go to TC Stats and see, get rid of that and make this 320, make this 320, calculate, it says seriously, and it gives you a 0. Now there's just a couple more scenarios I want to go through so you can figure out how to answer a variety of questions. So it wants to find the probability that you end up with between 240 and 378. So the probability statement would be probability that 240 is less than or equal to the amount of force required, which is less than or equal to 378. Now if I draw a picture, which you should always do, I've been known to give partial credit for a correct picture and a wrong answer. Here's 305. 240 is down here someplace. 378 is up here someplace. And I'm looking for this area under the curve. So if I go back to TC Stats, I need to make this a 240. And then this one was 378. And again, the mean's 305, standard deviation 28, and I'm talking about a single randomly chosen bottle. So I'll tap on calculate. That probability is 0.9853. So again, you need an English statement. And this statement would be something to the effect of the probability a randomly selected bottle of wine will require between 240 and 378 newtons to pop that cork is approximately 0.9853. Another way of saying that is you notice the 240 was the boundary line for not tight enough, and 378 was the boundary line for too tight to be comfortable. So the in-between is where you want to be. So they're saying that based on this industry standard, a little over 98%, about 98.5% of all the bottles are within the range that they want it to be. Sealed tight enough, but not too tight. Now, this is the last example I'm going to do. This is based on the information provided. What percent of wine bottles are either not sealed tight enough or sealed too tightly? So what they want is a probability that the force required is less than or equal to 240, or the force is greater than or equal to 378. If I draw my picture, 305 is the mean down the middle. 240 is over here someplace. I want that tail. And 378 is up here someplace. I want that tail. Now there's a couple of different ways that I can do this. I can go from negative infinity to 240, jot that down, then go from 378 to positive infinity, jot that down, add the two, and that's the solution. Or I could use the idea of complements. And you notice right here in the middle, I can find that by going from 240 to 378, which is what I just did earlier. So if the area under the curve is 1, then it must be true that 1 minus the probability 240 is less than or equal to the force, which is less than or equal to 378, must be equal to the probability the force is less than or equal to 240, or the force is greater than 378. And there's actually a couple of different ways you could write this. I wrote it like that. You could combine it. You could say the probability that the force is less than or equal to 240, or force is greater than or equal to 378, all in one statement. Doesn't really matter. And I hope you see why this works. Just as a quick reminder, I'm going to say the probability that the force is less than or equal to 240 plus the probability that 240 is less than or equal to the force, which is less than or equal to 378, plus the probability that the force is greater than 378 equals 1, because this is everything. It's just broke it up. Literally all I did is I defined this area, then this area, then this area. 1, 2, 3. When I add them all up, I get 1. So all I did was I subtracted off this middle piece from both sides, and I was left with the piece that I want. So you can do that, like I said, any way you want. I'm not going to actually answer it because we just did this middle piece. So you can take that, subtract it from 1 and get it, but you should practice this in TC Stats to make sure you can get the right probability.